Hi, I'm DJ Ware, and on this episode of the Cybergizmo, we're going to look at compiling a Linux kernel, a vanilla Linux kernel for Fedora Workstation, right after this. So you probably remember last time we talked we talked a little bit about bloat and trying to get rid of some of the stuff that is running on our system that we just don't need. One of the areas that you can look at is the kernel to not only remove bloat but also improve performance. And so we'll be talking about those today. So what are the steps that we need to do? Well, I have some scripts that I put together as usual, and that's what we're going to start with. So the first thing we need is a build environment in order to support the tasks that we'll need to complete in order to compile the kernel. And so what we're going to do is we'll first install a compiler, the GCC, the Flex, or the lexicographical analysis tool, Make, Bison, OpenSSL development, which you need because the packages all use signatures today, and then the ELF utilities, which are how to handle the executables that the kernel is having to deal with. And so we'll go ahead and do that first. I've already installed these, so they're just going to come back and say, nah, I'm not going to do that. I've already done it. The other thing that we can do is there's a few options that we can also include if we want. We'll need the ncurses development environment, and that's for the make menu config command. Also Qt or Qt development tool libraries are going to be needed, and if you're going to be using the xconfig application in order to do that as well. The other one is RPM build. Now, if I've compiled a Linux kernel, I might want to build an RPM out of it in order to take that build and take it to another server easily, without having to gather up all the stuff that I need and then forget the one file that was critical that won't allow the kernel to actually run. So RPM is a good way of doing that, obviously. And you can package either the source or the binaries, and we'll talk about those a little bit as well. So I'll go ahead and run this again. I've already installed these, so it shouldn't come back with any surprises. The next thing we'll want to do is we'll want to go to the kernel.org GitHub repository and bring down Linus Torvalds' his particular build. Now, today we're going to be using a mainline build. This is not a stable build, and so this would be used for testing only. I would not put this into production. But we're going to bring down the 5.3, the release candidate. The kernel build group does new kernels. Don't hold me to this, but generally it's 2 to 3 months. Just depends. Now I know when Intel had all their problems with Spectre Meltdown, they were working a lot harder on trying to get new patches out. And so, yeah, the 2 to 3 month might be sooner, might be later, but generally it's about in that time frame. I'm not going to actually download this. It takes quite a bit of time to do it. I mean, this is a big bundle of source code. I do have it already, however. And so we'll go ahead, and the next thing would be to untar that. Oh, yeah, of course. I might have to tell it what I actually want to untar, huh? So we'll go ahead and do that. As you can see, there's a lot of source code in here. At this point, then, I would take this. Now, this is the way I do things. You can do however you want to. You can compile it right here in your directory if you want. I like to move that build over to user source. And the reason I do that is so that I have all my sources for the particular kernel builds that I want to keep and track. I keep those in user source so that if, one, I need to go back to an older version, I can. Two, if I want to go look at the source code on maybe I'm having a problem and I want to go look at the source code and try to help the developers figure out what's going on, I can do that. So I've already done that part as well. I've cheated all along here. All right, so we've done that. So the next thing that you would normally do would be, let me let me just make sure that my window is big enough. We're going to be running curses, and curses was well named because that's generally what people do when they use it. It was meant to provide a menu interface for text that was pretty, but it's an abomination. I can tell you the horror stories that we used to run into with curses a long time ago with VT100 terminals or WISE terminals or any of those other pieces of garbage. Oh, sorry. There was just all kinds of problems with it. But if you want to blame somebody, AT&T was the inventor of it. So anyway, we'll go ahead and do that. We'll go ahead and do the make config. Hopefully my window is long enough to build this. So what it's done here is it's brought in a series of defaults. This isn't looking at anything that's on my system. Now this would be clean. If you've been in, let me explain this first, and then we'll go and I'll explain the next step of this. This does have some stuff in it that I did. So the first thing, let me go back out here. General setup. So the first thing I would do is in the local version, I would append some kind of name to it. And I'm going to put a dash in front of here. And that would then give somebody an idea who to blame for this. And this gets added on to the kernel name when it compiles. Don't touch this. That's the salt and for this build. General, unless you're a kernel developer and you're changing the version number, then yeah. You'll find some general things in here like System 5, IPC calls, POSIX, auditing, IRQ subsystem timers. Is this the? Yeah. Except those don't tell me what I really need to know. Well, do they? Full dynamic? Nah, I don't want those. All right. So one of the things you might want to change is this one. By default, I'm going to generalize this rule because I have not ever seen this where it was selected for server, even on server builds. It seems to always be put on voluntary kernel preemption. So the extremes. This is the high throughput model for servers. This is the low throughput, low latency model, and this is somewhere in between this and this. But you can get help on all these things, and it'll give you some indication or some clue of what's going on. But I can tell you that in the early days of Unix, this was the only choice you had, and that was that it whenever there was an interrupt or the system was going for I/O, there was a timer because Unix was originally time sharing. There was a timer that said, okay, stop, I'm just going to go do this. But then, later on releases of the system, users would complain that they were getting kicked, having to wait on something, or getting kicked off their application would stop running until it came back to them, because it would do round robin. It would run around in a circle and give everybody a time slice of the system. But what this is trying to do is trying to provide a mechanism where applications that are trying to push a lot of data have time to do it. And it's not really meant for the desktop workstation. If you're on a workstation, you will hate this because the applications are not going to give up control very easily. And so if you're going to pop open Windows, you're going to be doing a little word processing and open a browser and then go open a VM. Now this model is you're not going to be happy with this model. But if you're on a server environment and you have a database or an app server or a web server, yeah, this is where you want to set it. This goes back to the days where AT&T, when they were selling computers, they would make, this was their mantra, and that was one app per server. And the reason for that was this model, because when you started mixing a whole bunch of applications together, the performance overall would suffer. There wasn't a better way to arbitrate when to switch context to go to the next system, unless there was an interrupt or there was a fixed timer that said, okay, stop, go do this other thing. So enough about that. Let's go down here and look at this one. This one is really meant to lower the latency. Now, what are we talking about? So if you've done any audio, you know that there is latency between the time where I talk into the microphone, it goes through the processor and becomes digitized, and it gets encoded into a codec before I hear it. That amount of time, if it exceeds more than, I can tell you this, if it exceeds more than 7 milliseconds, it's going to drive you nuts. If you're trying to do a live performance and you're listening in your headphones and you're speaking into your microphone and there's more than a 7 millisecond delay, it's going to drive you absolutely nuts, because you're going to hear yourself talking and it's going to echo back, and it's noticeable. Over 7 milliseconds, it's noticeable. So the idea here is to try to shorten that time, and what this does is that the amount of time that any one of these processes get along the chain is smaller. And so there is more chance that this signal is going to get through sooner to my ear. But it comes at a cost of performance, because overall performance, my app doesn't have as much time to run. So if you're doing audio, maybe doing video, audio particularly, or if you're doing real-time applications where you have to respond within a certain number of milliseconds, like I can remember one particular case where a bank had, back in the days of checks, the checks would come through a check sorter, and then there would be a reader. It had a fixed amount of time between the time where that check was read and a pocket opened in order to get to the right pocket, and that would be using to route that check back to the bank. Of course, checking is dead today, but it's applications like that. We have a very small amount of time to make a decision before something happens, or if you're doing audio and you're trying to listen to a live stream. This one is putting it kind of in the middle between the server and the low latency, low throughput model. So this gives you better throughput, but not as good as the server model, but it gives you more interaction between applications. And so this is the ideal setting for desktops. And apparently the distributions feel that this is also a good model to use for servers. And it may very well be. Servers don't run one thing anymore today. You have Docker and you have some of those things that are mixing the app load. So anyway, that's something that you can play with. The other things that you might be interested in looking at might be things like device drivers. Now, one thing to comment here is that you'll notice some of these have M's and some of them have blanks and some of them have stars. If it has a blank, that means that this code, and I don't know why anyone would want ES. This is ESA support. That was a bus that was in IBM PCs and clones back late 80s, early 90s. It might have gone that far. It's pretty old hardware. If you need that, great. You can put it in the build into your kernel and it will be supported. But as you can see here, it's blank, so no code from the ESA support is going to be compiled into the kernel, and no module is going to be built to support it either. The star, or an asterisk, means that you're going to take the PCI code and you're going to make that resident. It's going to compile into the kernel and become resident. There's no module that's built. It is just part of the kernel. If it's a module, then you're going to compile the code as a module and you're going to store it. And the only time it becomes resident is if the admin or the owner of the system decides I need this support in my kernel, and they add the module at load time, at system boot time. So there's over 6,000 plus choices that you can make in here. I'm certainly not going to go through all of them with you today, but I think that's probably a good, no, I'm not going to save anything. So we'll go ahead and start a make, and we'll do a -J4. Now the J4 says to compile 4 different files at a time. C compilers, I don't know how many other compilers are actually multi-threaded, but compilers generally you can't multi-thread. It's just the nature of the way the workflow flows through the systems. They have to look at the source code a line at a time, and then they have to determine if it's syntactically correct, and they have to do a lexicographical analysis to determine how to build out the code, and then an optimizer in order to make it the most efficient assembly as you can. But this is the old model of threading, which is just throw 4 processes added at a time and let your machine choke on 4 compiles at once. Basically, that's what you're saying. The rule here is you take the number of cores, not threads in your system, the number of cores, and you multiply it by 1.5. And that gives you an optimal number for your system. Since this is running under a VM, I think 2 cores is all I got, maybe 4. And so we're just going to hit it because the operating system has enough cores to handle itself. So I'm not going to worry about this. Compilers, by the way, are I/O intensive, and so the kernel will be involved a lot during the compiles. This will probably take some time. Even though I have already compiled the steps, it's still got to slog through all the code. And as you learned last time, we're looking at over 15 million lines of code. And so it's just gonna, and my system is not one of the latest, so I haven't felt the need to upgrade yet. When it starts slowing down to the point where it's painful, that's when I usually upgrade. And it hasn't gotten all that painful yet, so it's starting to, but it's not quite that painful yet. It's funny how things go over time. I mean, the rule is that software expands to fill all available computing power, and that is certainly true. So we're done with the kernel. Now we're doing the modules. And then the next will be the blobs. I wish we could get rid of those. Those just take up so much damn room. So I've got 3,500 modules. If you were using a Raspberry Pi, you'll notice that the module count is much less. So at this point, we're done with this part of it. So we're ready for the next phase. Okay, I've done that, and I've done the next step. So we'll go to 6. And what it's going to do here is it's going to install the modules into the location where the kernel is going to expect to find them in case I do a load or a mod probe. It's also going to make the install script, which is to take what is built here and move it over to the boot directory. And then finally, grub2 is going to run in order to make a grub configuration file in order to put this kernel at the top of all the others so that I have a way back in case I break something. I'm always putting periods in front of stuff. So used to working in my home directory and not in here, not in the user source anymore. I just don't do that many compiles anymore. I used to do quite a bit of them, but not anymore. Systems are running fast enough that you might save 100 milliseconds. That's not worth it to me to wait on a compile that takes 90 minutes. But we're doing this for your benefit, not mine. So as you know, 3,600 of these later, we'll be done. Why would you leave these in? Well, you might leave these in if you knew that you were going to package this up and move it to different systems. Like, for example, if I'm compiling this on a desktop and I'm going to take this to a laptop, well, that's going to have different drivers in it. It's going to have different needs than the desktop is. And so that's why you might do this, is just save you time. You don't want to get so ridiculous that you're compiling a kernel specific to each machine you have. That's really makes it hard during an update cycle because you've got to go back and update every single one of your machines. And that would mean a new kernel compile for each one of those. And so that's just not, it's a question of time and effort, whether or not. So there's the last step. It's moving it to the boot directory, the moving it being the image, the kernel image. Next step will be to run the grub, which will then create a menu entry for this, which gives me a way back, right? And we want that. Even though this is on a VM and I don't care if it doesn't work, we just trash the VM. I don't do kernel compiles on bare metal. And I imagine you can guess why. It's because a lot of times if you're chopping stuff out of the kernel, you may hit dependencies that other drivers needed and that you needed that driver to be supported, and of course it won't work. So at this point, I think we're ready for the next thing. So the next thing would be if I wanted to create a package out of this. Now, I'm not going to show you this today. There's plenty of documentation on this, but basically there are two forms of packaging you can do. This one is doing a make on bin RPM dash package, which is just making a package of all the binaries. You can, if you want, do a source RPM. If you're a kernel maintainer and you want to keep a package of the source, you can do that. But at this point, we should be ready to reboot the system. And this will take a few minutes to bring in, because some of these kernels, some of these modules have to register. And so this will be a little slow on the initial boot. Or it could just be that VirtualBox is just getting slower and slower and turning into a pig, which I think it is. I think it is turning into a pig. I know. It's a sign that I need to upgrade, right? I need to go to a new processor. Yeah. Vendors never would do that, would they? They would never purposely slow down their software just to get you to buy hardware, would they? Nah, they would never do that. Okay, so let's go check this out. So you can see I'm now running on 5.3 RC5, and I have my fingerprints on it, so people can blame me for their failures. But anyway, at this point, you're not done. At this point, you would want to do some testing. You would want to see whether or not this kernel is working, especially this one. It's a release candidate, so you're probably going to run into some things that haven't been tested very thoroughly. And so you would want to test your application with this and make sure that it's working. At this point, I have completed what I wanted to show you today. I hope you enjoyed this. And if you did, please like and subscribe. And as always, hope to see you again real soon. And bye for now.